let's have a look now at some examples of how to compute indefinite integrals. These are going to be very basic examples just to give you some idea of some of the work that I expect you to do on your own, both to find out more integration formulae as well as to get more acquainted with these antiderivatives. Notice I'm using antiderivative and integrals interchangeably. Remember, they're the same thing, so I'll use sometime one, sometime the other. All right, so let's start with the first example, and that's trying to integrate a function in the form x to the power n. Again, I'm sure you have seen this formula before in your high school, but I want to make sure that you understand where it comes from and what the connection to differentiation is. So we start from the power rule for derivatives. Okay, so how do we take the derivative of something of the form x to the power n? Well, we use the power rule. What does that power rule say? Well, first of all, we're going to multiply x to the power n by the exponent. So we're going to write the n in front times x to the power n, and then we're going to decrease the exponent by 1. And so that makes it n times x to the power n minus 1. Notice that we do these things in order. First multiply by the exponent, then we decrease the exponent by 1. So if we're going to go backwards, we're going to have to invert the procedure. So what does that mean? Well, it means that in order to compute the integral of x to the power n, first we have to increase the exponent by 1. So our exponent will become x to the power n plus 1. And then, second, we're going to do what we did first, but in reverse direction, of course. So when taking derivative, we multiply by the exponent. This time we're going to divide by the exponent, and that gives us the formula which should be familiar to you of x to the n plus 1 over n plus 1, right? No, it's not right. Remember, this is a general antiderivative. What do we have to do? Yes, add c. Okay. Oh, there's one more thing to notice here. Can you notice it? Do you see what's wrong with this formula? Yes, that's right. It's not going to work if n is going to be equal to -1, because in that case, we're going to divide by 0. So this power rule formula will in fact provide us with the antiderivative for x to the power n as long as n is not equal to -1.